Welcome to Day 3 of Calculus Unit 1. And in this unit, we're going to look at solving trig equations, proving trig identities, and review the unit circle. Now, my review of the unit circle is short and quick. It's just this: know the unit circle. Please know that in this class, we always use radians. So please make sure that your calculator is in radians. That's especially important for those kids who are taking physics, because I know you did degrees in there. But you want to make sure that your calculator is in radians. And you want to memorize the unit circle. You just got to do it. Okay, so we're going to prove a couple of trig identities. Remember, in proving trig identities, it is not an equation. So that means that what we do to one side is not necessarily what we do to the other side. You take each side individually, and you try to simplify each side individually. You determine which side seems the easiest to simplify. I always want to try to get everything in terms of sine and cosine. Since this is already in terms of sine and cosine, I'm going to start by trying to simplify the left side. So cosecant is 1 over sine x. Cotangent is cosine x over sine x, which this becomes 1 plus cosine x over sine x, because they have the same common denominator. All right, but that does not look like this. So what can I do to this? I have to make sure that I keep the integrity of this side of the equation. So I can't square it, I can't multiply it by something because I change its value. But I can multiply by 1. So multiplying by the conjugate doesn't change it because we're just multiplying by 1. So that gives me 1 minus cosine squared x over sine x. Now on your sheet, I've given you some basic trig identities, and we know that sine squared x plus cosine squared x equals 1. Therefore, 1 minus cosine squared x is sine squared x. And simplifying this, I simply get, what did I do wrong? Oh, I didn't write that out completely. This should be 1 minus cosine x. Wait, what did I do wrong? Okay. So that gives me sine squared x over sine x, 1 minus cosine x. And this sign cancels with this sign, and I'm left with sine x over 1 minus cosine x. And that is what I started with. So I have proven the two are equal. For this one, I'm probably going to have to use two identities. Again, if you look in the middle of your paper, the top of your paper, remember that sine 2x is equal to 2 sine x cosine x. Okay? So I haven't really done anything to that side. I just rewrote it because that's going to help me in a minute. So I know that tan x is sine x over cosine x. Because remember, you always want to try to get everything in terms of sine and cosine. And this would be 1 plus. Now cosine 2x, again, from the middle of your paper, cosine 2x is cosine squared x minus sine squared x. Everything in terms of sine and cosine. Multiplying this out, I get sine x over cosine x plus, when I multiply this, this becomes sine x cosine x, because the cosine will cancel, minus, before I do that, one of the things about this, I always tell kids do this with an eraser, good eraser. One of the things I noticed, I'm going to simplify a little bit because I was getting a little crazy. I know that 1 minus cosine squared x, I know what that is. 1 minus cosine squared x, 1 minus sine squared x is cosine squared x. So this becomes sine x cosine x times cosine squared x plus cosine squared x. Or sine x cosine x times 2 cosine squared x. Now this will simplify with that, and that's going to give me 2 sine x cosine x. There we go. Everything in sine and cosine. All righty, cosine squared x again, I want to simplify the most convoluted side. So this side is more convoluted. So I'm going to leave cosine squared the same, and I'm going to write cosecant is 1 over sine x times cosine x. And tangent x is sine x over cosine x. Cotangent x is cotangent x is cosine x over sine x. Okay? So now I have cosine x, sine x, and here I'm going to find the least common denominator. So to find that least common denominator, I can do it's sine x cosine x, so that's going to give me sine squared x plus cosine squared x all over sine x cosine x. Okay? Do I know sine squared x plus cosine squared x? I do. So now I have cosine x sine x, and I'm going to multiply by the reciprocal because I'm dividing, and that's going to give me sine x over 1, because sine squared x plus cosine squared x is 1. Sine x cosine x. I dropped a cosine there. All right, so sine x's cancel, and I'm left with cosine squared x, and I have proven the two are equal. All right, let's do a couple equations. All right, so for this equation, it looks quadratic because I have squared here and a first power here. So this looks like a quadratic equation, so I can solve this like it's quadratic. I'm going to let u equal to sine x. Then, of course, u squared is equal to sine squared x. Now, replacing each of those, I get 2u squared plus 3u plus 1 equals 0. Now, I could use the quadratic formula to solve this, but factoring is going to be your best friend in this class. So let's practice factoring. I know you've been taught all kind of goofy methods of factoring, but we want to go back to just guess and check, okay? So I need to multiply two numbers to get 2. What two numbers can I multiply to get 2? Well, I'm limited. The only two numbers I can multiply to get 2 are 2 and 1. I need to multiply two numbers to get 1. Well, again, I'm limited because the only two numbers are 1 and 1. So now I need to check to make sure I get 3 in the middle, and you should be able to fall in your head. We know that the 1 is positive, so either both of these values have to be positive or they're both negative. Because the 3 is also positive, I know that both of these values are positive. So when I guess and check, if I were to multiply here, I get 2u, and when I multiply here, I get 1. I'm sorry. When I fall this out, I get 2u, and here I get 1u. So 2u plus 1u gives me the 3u in the middle. So I know I have factored this successfully. Now I can do 2u plus 1 equals 0, and u plus 1 equals 0. Well, I get u is equal to negative 1/2, and u is equal to 1. But remember, I'm not solving for u. I'm solving for, because u is sine x. So sine x is equal to negative 1/2, and sine x is equal to 1. When is sine x equal to negative 1/2? Well, sine x, that's negative 1. Sine x is equal to negative 1. That's the easy one. That's 3 pi over 2. To find out when sine x is negative 1/2, I want to use my handy-dandy unit circle. And I know it's going to be in quadrants. Sine is y, so it's going to be quadrants 3 and 4. So sine is negative 1/2 at 7 pi over 6 and 11 pi over 6. So sine x is going to be 7 pi over 6 and 11 pi over 6. Notice that ask you to solve this from 0 to 2 pi, so you don't have to worry about the other intervals of that. Okay? This one, what are we going to do with this? I have cosecant, I have a cotangent. I don't have anything in common. It's not quadratic. So let me start by taking everything to sine and cosine. So cosecant is 1 over sine x. Cotangent is cosine x over sine x, which now I have 1 plus cosine x over sine x is equal to 1. Okay, if I want to solve this, I can multiply both sides by sine x. That's still not helping me any. So as long as, because this is an equation, what I do to one side, I can do to the other side. So I'm going to square both sides. So that gives me 1 plus 2 cosine x plus cosine squared x is equal to sine squared x. I know that I can rewrite this as 1 minus moving the sine squared x to the other side. Okay? So that helps me because now I know that 1 minus sine squared x is what? Cosine squared x. So that's cosine squared x plus cosine squared x. So that together gives me 2 cosine squared x plus 2 cosine x equals 0. And so because it's equal to 0, I can solve by factoring. I can factor out a 2 cosine x, and I have cosine x plus 1, which gives me that either cosine x is equal to 0 or cosine x is equal to negative 1. So cosine is 0 at pi over 2. Cosine x is negative 1 at pi. Okay? But we have to make sure that both of these answers will work. If I go back to my original problem, sine can never be 0 because I can't have 0 in the denominator. So sine of pi is 0. Therefore, pi is what we call an extraneous answer because it doesn't work in the original domain, and my only answer is pi over 2. One of my suggestions for that would be to graph it, and you can see that there was only one answer when you graphed it as well. Okay, I want to do a couple of more of these, but I'm running out of time, so I'm just going to try to do maybe these 3, and hopefully that'll be enough for you to get started on your homework. All right, so I want to do this because, again, I found that kids have problems factoring, so let's factor. So I'm going to let u equal to sine x. Okay, so this becomes 2u squared minus 5u plus 2 equals 0. So I'm factoring this, and I'm going to use guess and check. All righty? So 2, the only possible choice for this is 2 and 1. But now I have different possibilities for 2. I can either do 1 and 2 or 2 and 1. I have to figure out which one it is, okay? I know that because this is positive and this is negative, that means that they're both negative. So if I put 2 here and 1 here, when I multiply that out, I'm going to get 2u minus 2u, which is 4u, and that doesn't work. So if that doesn't work, so let's try something else. So let's try switching the place of the 2 and the 1. So if I put 2 here and 1 here, when I multiply that, I get negative 4 and negative 1, which gives me negative 5 in the middle. So now I am cooking with grease. So now I can say that u, which is sine, so sine x is equal to 1/2, and sine x is equal to 2. When is sine x equal to 2? Never. It's outside of the domain. Remember, sign goes from -1 to 1. So sine x is equal to positive 1/2 in the first and the second quadrant. So that would be at pi over 6 and 5 pi over 6. So x is equal to pi over 6 and 5 pi over 6. Okay, 2x and cosine x are different. In order to solve this, they all need to be in terms of cosine x. But remember, we have our handy-dandy little table over there, and we can write that 3 cosine 2x is the same as 3 times cosine squared x minus sine squared x minus 5 cosine x is equal to 1. Okay? So what is that going to give me? I'm going to have to change sine squared x to 1 minus cosine squared x just to get everything in terms of cosine. So I have 3 cosine squared x minus 1 minus cosine squared x. It's going to get confusing. Minus 5 cosine x equals 1. So multiplying this out, I get 3 cosine squared x minus 3 plus, because this negative and this makes that positive, 3 cosine squared x minus 5 cosine x equal to 1. Okay? So combining like terms, I get 6 cosine squared x minus 5 cosine x, moving the 1 to the other side, minus 4 equals 0. Okay? That's all I have time for today. I hate that I'm going to have to let you solve this one on your own. You're going to have to factor that. And again, we're going to use guess and check to factor. So this is going to be a little bit more difficult because there are a lot of ways I can get 6. I can do 2 and 3. For 4, I can do 4, 1, or 2 and 2. And you're just going to have to kind of guess and check with that. This is negative, so one of them is going to be positive and one of them is going to be negative. If I did it this way, I get 4 and 6. That's not going to give me what I need in the middle. If I did 4 and 1, that'll give me 2 and 7. So that'll work. No, that'll give me 2 and 12. So that one won't work either. So you have to guess and check with that and figure that out. Anyway, we will do these in the morning, and I will see you then.